Hello everyone! Today I want to take you into one of the most daring, futuristic, and unsettling scientific topics, one that forces us to ask ourselves a harsh question. Do we really understand light? Because if you ask a first-year physics student, or even many scientists, the answer will come immediately. Light is the fastest thing in the universe. It travels at 299,792,458 meters per second. It is a constant of nature. Nothing can go faster. But a question emerged in the past few decades, one that made physicists around the world momentarily hold their breath. What if we could make light slower than nature intended? What if we could slow it down by 1,000,000 times, or even slow it all the way to a standstill? It sounds like science fiction, but today it is real, and the frightening part is this. Once light slows down, the world stops behaving the way we think it does. Some laws of physics seem to open cracks through which humanity can peek at the secrets of time itself. I want you to imagine walking into a laboratory, a room where light is no longer something so fast it can't be seen, but something that moves sluggishly like drifting smoke. Light bends, stops, gets trapped, gets released, as if it were a physical object. You could freeze it in front of you, like pressing pause on the universe, then let it continue again. This story became serious in the late 20th century when a physicist named Len Howe from Harvard announced that she had slowed light to just 17 meters per second, and at certain moments brought it to a complete stop inside a cloud of ultra-cold atoms at less than 1 microkelvin. The scientific world went into chaos because it was as if someone said they had halted the arrow of time. Even more chilling, she used no magic, no black holes, no time-warping machines, just the cold vapor of rubidium atoms and a technique called electromagnetically induced transparency. That was the beginning of all the madness we are talking about today. And I want you to keep one question in your mind as you listen. If light is the messenger of the universe, if it tells us what happens, where, and when, and defines the flow of time, then if we modify light, aren't we modifying our perception of time? And how likely is it that humanity is approaching the first doorway to stopping time, just like in science fiction that has been written for 100 years? First, we must understand that the light we know is not like a ball being thrown. It doesn't move the way we imagine. Light is a wave of electric and magnetic fields that arise simultaneously, and it interacts with the medium it travels through. In vacuum, it travels fastest, but through water, glass, crystals, or certain exotic materials, it slows down. That is the loophole of nature. We are not weakening light, rather the material forces light to adapt, to slow down like a car entering a sharp curve. So, what if we create a medium even more extreme than water or glass? That idea launched the experiments that slowed light down to slower than a walking human. Other experiments held it suspended in midair for seconds, storing its information, like inserting a message into light and freezing that message in space before releasing it again. Think about this. Our world depends on information. Light carries internet data. Light carries the images from your phone camera through fiber optics. If light can be stopped, then we may be glimpsing a new era of quantum computers where information can be frozen into tangible chunks. But what I want you to focus on is not the benefits, it is the cosmic implications. Slowing light might reveal that the laws of time are not as rigid as we believe. The first thing that happens when light slows is the distortion of our own time reference. If you take a picture of an object and the light is delayed by a medium before exiting, you see the image later than reality. Your perceived time shifts slightly. Now imagine doing this with every ray of light bouncing off every object in the room. That room might have multiple time speeds layered on top of each other without anyone noticing. This leads to a provocative idea whispered among some physicists that extreme light slowing in a lab is essentially a test of the question, is time absolute or merely a product of the information carried to us by light? There is an obscure but fascinating experiment. Researchers used the pulse of light that had been stopped, then manipulated it with magnetic fields before releasing it. The resulting information changed slightly, as if we whispered into the arrow of time before letting it move again. You might think this is just equipment noise, but what if it isn't? What if time can be edited ever so slightly while we freeze it? Furthermore, when we talk about light slowed by 1,000,000 times, slow enough for the human eye to watch it crawl, we're discussing a condition the human brain was never evolved to perceive. We see light as maintaining constant speed so our world makes sense. But when light moves slowly enough to resemble a droplet drifting through the air, we begin to witness the universe operating in a mode humans were not built to understand. Many people misunderstand the idea of stopping light. It doesn't mean freezing photons mid-flight. In reality, stopping light means converting the light's energy into the quantum states of atoms, storing the signal of time inside matter's memory, then releasing it later. This has led some physicists to propose a radical idea. If we store enough light inside matter, then release it in patterns we choose, we might create a region where time flows differently from the outside world. We are talking about a laboratory room where time no longer needs to flow forward at the same rate as in the outside world. And though it sounds extreme, nothing in modern physics forbids this, especially within quantum field theory and emergent space-time concepts, which propose that time and space might not be fundamental, but emergent from intertwined quantum information. Light carries that information. Therefore, whoever controls light may be directly touching the structure of time. Imagine the world 30 years from now. Picture a laboratory filled with nano-Kelvin gases, blue laser beams crawling like living creatures, floating through visible quantum mist. A physicist stands nearby holding a tablet that can stop light as easily as pausing a song and resume it with a tap. Now ask yourself, if one room can stop time for a few seconds, would the outside world remain the same? What if it became a minute, 1 hour? What if people inside could work for a week while only minutes passed outside? What would we call that? Research? A physics tool? Or magic for the new scientific age? And all of this began with the simple question, can light be slowed? The answer is yes. And when slowed by 1,000,000 times, it is no longer merely a physical phenomenon. It becomes the opening chapter of an era where humans begin to touch the limits of time, raising a question no one dares answer. If we can stop light, what else might we someday stop? Perhaps data, perhaps events, perhaps memories, or perhaps even time itself. That is why light slowed by 1,000,000 times is not just cutting-edge research. It may be the very first door into the forbidden zone of the universe where humans start influencing something once believed untouchable. And all of this journey began with a tiny question about whether light can be slowed. And now it has brought us to the point where we are touching the deepest structure of time. If you've listened this far, you'll understand that slowing light is not merely a physics technique. It is a way of peeling back a thin wall of reality and looking into what lies beneath the natural laws we know. Every time we change the speed of light, we twist the dial of time itself, even if only by a fraction of a second. And that is enough to remind us that the universe may be far more complex than textbooks have ever suggested. I want you to think again about this. When humanity can stop light reliably, controllably as a basic tool, what will we do with that power? Will it change how we store information, communicate, build computers, or even redefine our understanding of the present and the future? Or will we finally discover that time is not linear, but something we had misunderstood because we were born into a world where light is simply too fast for us to ever see its true nature? Whatever the final answer is, science has reached the point where we are not only questioning the universe seems to be questioning us. Are we ready for the truth, or will we stop at the threshold out of fear of what lies beyond? But regardless, I hope today's story shows you that knowledge never stays still, just like light, which we once thought could never be stopped. Every new question pushes the universe open by one more step, and perhaps slowing light to a standstill is only the first chapter of something far greater waiting for us in the future. Thank you all for staying with me for so long. I hope you found inspiration, excitement, and new perspectives about light, time, and the universe. If you enjoyed this journey, join me again next time as we explore another hidden layer of the scientific world that is now rewriting history. For today, thank you very much, and see you again soon.